Good morning, everybody, and thank you very much to FESPA for inviting me here to present. Following on from Ron's talk, I will be talking about printed electronics and 3D printing. Oh, skipping forward, I'm just trying to go back. There we go. So I've been given the quite challenging task of trying to summarize these two industries in 20 minutes. And I'm really going to focus on where the technology is today, but specifically look at how printers are already making money in printed electronics. There's a whole range of applications out there, some quite large markets, and I'll be covering those different case studies. One slide about idtechex, for those of you who are new to us. We are a market research and technology scouting firm. We don't make any technologies, but we assess what is going on in the field of several emerging technologies, including printed electronics, 3D printing, wearable technology, and the Internet of Things. We do this mainly through extensive interviews with companies throughout the whole industry to find out what are the opportunities, the areas of oversupply, market sizing, and so on. And we disseminate this in the form of reports, subscriptions, and events. We are based around the world because we deal in technologies which are very global, and we have customers in 80 countries to give you some idea of the scale of these emerging technologies. Now, I always like to start by looking at what the problem is, because there's always a lot of new technology push with new technologies and people who hype it up. So it's important to step back and interview the end users, find out what they're really looking for. And if we look at printed electronics, there are many drivers why companies throughout the world, particularly in consumer goods brands, are looking at printed electronics. One of the key reasons is this increasing friction between consumer goods brands and retailers. Because retailers, of course, own the store, and consumer goods brands have to sell through them. They tell them their marketing plans months in advance, and they spend a huge amount of money and decades building out brands, which almost overnight is copied, slightly changed by retailers. And the picture in the top right shows a Diageo brand. Diageo is the world's largest alcoholic drinks maker. They own the Pimm's brand. It's a brand that's decades old, and they've spent a lot of money developing it. And overnight, the retailer, in this case Sainsbury's UK, brought out something which you can all see looks very similar, and it's being now sold in competition to the Diageo brand. Diageo tried to sue Sainsbury's over this, but then withdrew that because at the same time Sainsbury's is one of their biggest customers. So it puts them in a very difficult position. And this is happening to most brands around the world. Retailers are doing this because they're also under pressure now from discount stores, so that's their angle. But it means that consumer goods brands are in a very difficult position, and so they're looking to new technologies to help them differentiate their products, and printed electronics is one of them. And in many cases, many of the brands that we talk to and we deal with are looking to create IP around printed electronics for their brands so they cannot be copied. We also have many other mega trends. For example, we have the aging population. In the bottom right, we have an image of the number of elderly people as a percentage of the population that need to be dependent on other people. And this is based on various government reports. And by 2040, Italy will have a population whereby 60% of the people living there will be reliant on people, younger people, that don't really exist, and not enough of them. That means we need to use this new technology to do things like improve drug delivery, so people can stay in their homes for much longer, rather than these blister packs where a 3-year-old child can get into them as well as an 80-year-old person, or the microprint on the instructions where the pills are, the label on the pill bottle is barely readable. And print electronics and other technologies I'll be talking about are beginning to help tackle all these problems. It goes beyond static color imagery to one day you will walk into a supermarket and everything will be screaming out at you. There'll be moving flashing displays. You may not like it, but in the same way, color print took over from black and white prints because it helped companies differentiate. And so too will printed electronics help brands differentiate their products from everything else. So what is printed electronics? Very simply, it's really an umbrella term. We talk about technologies which can be printed now, but also technologies which are not printed yet, but which are moving towards being printed. One example of that is the OLED display, which is in, say, your Samsung smartphone. That's based on or manufactured by a non-printing process, but the companies behind it are working on printing those in future, because then they can get the manufacturing costs down and they can get to larger and larger area displays and TV sets. So it's really going from bulky 3D electronics with lots of components which need to be integrated to thin laminar formats, which can be printed or partly printed. The benefits are lower cost. If we look at the electronics industry, the cheapest silicon chips are in the region of a few US cents each, and they're sold in tens of billions each year. With print electronics, we hope to bring the price down by magnitude, which means the volume of these devices can go up by 2 magnitudes. So eventually we will move from tens of billions of electronic devices to trillions of electronic devices, where we can really start to have disposable electronics for the first time, enabling this Internet of Things vision. However, we need to be realistic. It will take time. It took 70 years for silicon to get to a few cents per IC, and maybe print electronics will do it in 35 years, in half that time. And we're 10 years into that process already. But that's only one part of print electronics, and there are many other aspects of print electronics which are available now. Then there's form factor. Print electronics is enabling new applications because it's not bulky, rigid electronics, it's flexible electronics. In some cases, it's better than existing electronics, but it's also about production. It's moving electronics to much higher and larger areas, which is relevant to displays, solar cells, large area sensors, and so on. So this is the value chain for printed electronics, and if we go through it in a bit of detail, we see that most investment is being made by material companies. They're looking to create a huge amount of IP and sell high added value materials for the years to come. In the same way that companies like Merck made huge profits selling materials to the LCD industry, they're ploughing those profits back into R&D for print electronics materials. There are also many print electronics materials which are simpler, such as conductive ink. And so far, billions has been invested by material companies to develop these material inks. We then have the equipment providers. Already in print electronics, most of these companies we speak to are profitable, selling equipment dedicated to printing conductive ink or functional circuits, but fairly low revenue because most of this is going into R&D. So a typical printer provider for an inkjet printer, say, into the print electronics industry has revenues of a few $1 million to about $10 million. There's also gravure printing, die slot coating, and many other types. It's beginning to be used for higher volumes now, particularly screen printing, which has for a long time been used for things like membrane circuits, which Ron mentioned, but also printing things like the bus bars on PV and other case studies, which I'll come to. And then we have the product creation side. There's been a lot of technology push from the left, but so far fairly little user pull because the users are not very well educated about what print electronics can do, and they're not really sure what to ask for. And so these two industries have to come together. We have lots of people making different components, whether it's a display, sensor, transistor, or printed circuit, but very few people trying to come up with a creative product because a transistor isn't a product, neither is a battery. And end users don't want to do integration, they want complete solutions which offer value proposed to them. So, summarizing the industry, just one slide on our data to give you a view as to the size of the sector. This includes technologies which are not printed yet in some cases, but moving towards being printed. And it's really to show you that print electronics isn't just one technology. It's a whole range of enabling technology at very different states of maturity, commercialization, and profitability. The biggest has been things like OLED displays, and they're not made by printing yet, but companies like Panasonic are working on printing OLED TVs, and they are shortly due to announce when they'll bring that to market over the next few years. Others are working on printed electroluminescent displays, which is now actually in decline because that's being replaced by LED backlighting, which is more efficient. We have people working on printed solar cells, and others on different components such as thin film batteries. There's a whole mix, and you can see some of these have been developed for a long time, very small revenues and not profitable, so there's been the inevitable shakeout over time, but we're beginning to get to the point where we're beginning to see more integrators put these different components together to make useful things. So the ways that print electronics companies are moving to market are as follows. One way is that people are looking to replace complete products. For example, replace an LCD television with an OLED television. Eventually that OLED television will be printed. That requires huge investment, and there's been inevitable shakeout or acquisitions. And to give you some idea, about $15 billion has been invested in OLED displays so far. None of them are yet printed, but the companies are investing in printing them. We then have companies who recognize they cannot take on that huge task. They cannot do everything themselves unless they're a Samsung or Sony or LG. So they're looking to improve an existing layer or component in a device. One of the biggest markets for that is the glucose test strip market, which is shown here. So the glucose test strips are sold each year to people with diabetes. About 28 billion are sold each year, and 85% of those are made by printing. It's a $6 billion market. That's just the printed ones, and they're made by companies like Abbott, Johnson & Johnson, and so on, and they've been printing them for years. The cost to print them is a few cents. The retail price of a single glucose test strip is about 70 US cents. There's phenomenal margins involved. Now the trend is towards higher resolution because they want to do multiple tests from that blood and combining it with things like microfluidics, incorporating a printed structure. So already there are billion-dollar markets based on printing functional materials, and people have been doing these fairly quietly for many years. Then there's others, such as people who are using printing to print things like better batteries and supercapacitors, which are going into consumer electronics and lightweight sensors. But a key opportunity, and perhaps the biggest opportunity for printed electronics, is the one where the market isn't defined. It's about creating products that people want, but they don't yet know they want them. They don't exist. And the best example of that, based on printed electronics, has been the e-paper technology, which Amazon commercialized in the form of the Kindle Reader, which didn't replace anything. It didn't replace your laptop. People bought this in addition to that laptop. And it created a market, literally overnight, of billions of dollars for companies like Amazon who use that as a content medium. Now that's in decline. Already it's peaked, it's going down, because for the same reason that people don't buy black and white televisions anymore, they want color versions of this. And so the companies involved are working on color versions of bistable displays. So at this point in time, we've seen more end-user interest in printed electronics than ever before. Almost every major consumer goods brand we speak to have people dedicated to working on printed electronics, mainly at innovation and research level. They don't yet have products to show the marketing people, because the moment they do that, they need to have very high volume manufacturing capability, which isn't quite in place. But they're all looking to create IP around new applicational ideas. And over the next few slides, I'm going to show you what already exists today and has been commercialized based on printed electronics, and it may interest or inspire you. So these are all commercial products based on printed electronics, and it gives you just a range of what's out there. Some of these may be frivolous, but they've resulted in high volume sales for a lot of their customers. If we look at the bottom left, you may recognize the Duracell battery tester. This is a Procter & Gamble brand. Avery Dennison print this, roll-to-roll printing, 9-stage process. And this allowed Duracell to premium price that product. But the key differentiator is that because this was a fairly novel feature when it came out, the supermarkets put it on the tills, and any product that goes on the tills sells much more. So Duracell also got a major payback that way. And of course, what they don't say much is that when you test the battery, you effectively short-circuit it, so the batteries run down much more quickly. But it's a very simple printed electronics device costing about 5 cents each. At their peak, they're printing 300 million a year. We then have companies who are trying to do something different on the supermarket shelf. So Kent Cigarettes in Japan had 1 million multi-pack boxes which had printed electronics, and when you press the button on the top left, that logo lights up. That's because they can't advertise anymore very easily in cigarettes, in billboard posters. They have to do it on the package. Then we have McDonald's, who in Australia printed 100 million tray liners with conductive ink on them, with conventional coin cell batteries and LED, but as you moved the toy around, the LED would light up in certain places or not. Just printed silver ink on paper, which was then thrown away, 100 million of them, and they've been doing that for quite a few years now. In the media world, we have organizations who have brought out interactive magazines. The high price of the electronics meant that these have been one-off editions and sponsored. Back in 2008, Esquire magazine had Ford sponsor the e-ink display going to the front of it, and the most recent one was Wired magazine in the US in December, which had a Motorola-sponsored ad, which you press a button and the color of the Motorola phone changed. On the bottom left, we have labels with printed electroluminescent displays. This is Ballantine's whiskey, sold in Europe. This is only going to trade sales. But here what happens is that in the base you have the conventional electronics, but what's printed is the display label. And so as you go into a bar or a nightclub, it's the only bottle which lights up and is moving. So you're attracted to it and you use it. As a result, sales have gone up, and now other brands, Bombay Sapphire, are doing the exact same thing. So it's printed electronics on packaging today. Then we have the healthcare market. This is now an example of companies creating completely new markets. Let's look at Estee Lauder, top left. On the reverse of that skin patch is a printed battery and printed conductors. This is a cosmetic patch, and they sell them so you put them on your face where you have wrinkles, and the power put over the skin opens your pores up, and the cosmetic goes in 10 times faster. It's a medical effect known as antiphoresis, and people actually use it to deliver drugs that way, but this is done for a cosmetic patch. And so really it's the modern day Cinderella story. You apply this for 20 minutes, your wrinkles go away, and then 3 hours later they all come back again. But they sell this at a premium price. They sell 5 pairs of these patches for $150. And this is only enabled by a printed flexible battery because people wouldn't strap a coin cell battery to their face. Now another company, BioBliss, has launched a similar skin patch, and where this is going is that companies are now in the process of getting approval by the FDA and other associations to not just put cosmetic into you, but put small molecule drugs into you, and even sense the need for drugs and put them into your body. So now we can idiot-proof drug delivery. We don't have to rely on people taking their pills on time. The patch just does it for you. At the bottom left, we have an example of an issue of medication non-compliance. This is someone who has diabetes, and the blue line shows their glucose level, and the red vertical bars show when they haven't taken their pills on time. And so you can see it spike, and then they sometimes compensate by overdosing. If you look at the treatment for something like HIV, in a 6-month treatment, if you take a single pill a day too late, the effectiveness of the whole treatment, even if you do all the other pills on time, can fall by half. So taking your pills on time is very important, and that's why we have companies such as GlaxoSmithKline and Pfizer already exploring using printed electronics in smart blister packs as a hybrid device. So when you push that pill out through the pack, it breaks a printed circuit, and they know when that pill was removed from the pack. As a European company, you're even looking at using a patch to give you a slight tingle on the skin to remind you when you need to take that pill. And then we have large area. These are all commercial examples of printed functional inks used already today for advertising. This is printed and organic electroluminescent displays used for billboard posters. And the negative of this technology in particular, and the reason why you don't see this everywhere, is that it only works well in this case in where it's darker, so not in bright sunlight. And that's why, in particular, this one display technology is limited, but it's now being replaced by people who are working on things like printing LEDs. And then we have the consumer electronics world, print replacing conventional switches. And this is a really hot area at the moment in the print electronics industry. And Ford, one of the companies who are looking to roll this out. But in this case, Ford are replacing the switches in the top instrument cluster in your car. These are mechanical switches with copper wiring, so it's heavy. You have moving parts which are prone to failure. They're all going to be assembled. The whole thing is bulky. What's happening is that companies have developed stretchable inks. So now on a flat sheet, they print the switches. So we have solid-state capacitive switches, nothing to move anymore. It's lighter weight. There's no copper wiring. And then it goes through an in-mold process. So you end up with something on the right, which is a 3-dimensional molded part, which has had printed conductive ink for the switches and sensors. And Ford are rolling this out to the Ford Focus cars, and they've rolled out 1 million so far. And we're seeing many other car makers begin to look at this for switching. And finally, just to give you an idea of what's going on, we're beginning to have convergence. So a lot of print electronics today, as you've seen, is hybrid. People are printing one part or another part, starting off with the easier things, such as conductive ink. But now companies are looking to print more and more, and they're beginning to build ecosystems around building complete solutions. So this one organization, Thin Film, based in Europe, are printing the logic, the memory, the battery, and the display to create a digital time temperature label, which they're looking to go into the packaging market, the healthcare market, to monitor temperature of blood and so on, with the whole device being completely printed. It's printed with many different technologies. It's gravure, it's inkjet, it's screen printing, and they're working with different partners to bring this together. So we're beginning to see completely printed, flexible, low-cost devices. And initially, of course, a lot of these technologies will not try to compete on cost. That would be wrong because so much investment has gone into it that they're not necessarily cheaper. But it's the other benefits, such as being lightweight or flexible, which are the key selling points and indeed reasons to premium price these products. So to summarize the print electronics part, there already have been $4 billion industries which have been created in this world of printed electronics. The first is OLED displays, which admittedly isn't printed, but it's moving towards being printed. The second are e-readers, which we discussed from companies like Amazon and others. Then there's the market just for conductive ink, which is going into your car windscreen heater for years, membrane circuits, but also now it's been printed extensively on solar cells as the bus bars for smart packaging, which I've spoken about in a few examples. And then the glucose test strip market, which is printing billions of these each year. So it's a very dynamic and busy space that we try and track all the players in it, and there's over 4,000 players so far that we've tracked in print electronics, all the way from the research level within universities to major organizations heavily investing in it. There's a significant amount of end user interest. It has been 10 years of technology push, but now we have some very excited users looking at it. And in terms of the opportunities for printers in this room as to how you can make money, well, firstly, I think it's very different from what you're doing now. We speak to a lot of people who already print something and believe they can easily get into printed electronics. To do that does require commitment, investment, and time. It's not just a straight swap. However, there are many opportunities we think for printers, including printing elements of systems, such as the switches that Ford are using, for example. The industry is very bad at coming up with creative products, and you have the channels through to the end users, so you can work with them to educate them about what can be done and create products they want, and then integrate the necessary components to achieve that, and you can create IP as you do that. And integration is also a key opportunity. And then briefly, I've been asked to cover 3D printing, which I'm doing separately, because so far it's fairly unrelated. I just have 2 slides on 3D printing. So this is the basic value chain. The 3D printing has been around for 25 years, but the key change was that in 2009, some of the key patents expired, and that's why we have the flood and the media noise that we have now. It still, however, is a duopoly market. There are 2 main players that hold most of the patents and sell most of the systems. And they have phenomenal markup on materials. They're buying materials in and selling them for a few magnitudes more without adding any value to them, and that will slowly start to change. And those 2 companies, Stratasys and 3D Systems, are now in acquisition mode based on their high valuation to try and protect their core business. But over the next 5 years, a lot of the key IP around 3D printing is expiring, so expect to see a flood of companies coming into the market, including companies like HP, who later this year will be announcing their 3D printing solution. Today we have 3D printing mainly being used for prototyping, and increasingly things like jewelry, where you can already go online and have your custom bit of jewelry made. The future is in production on a one-off basis, so it won't be used to produce many components all the time. It's too slow for that. But where, for example, you need a spare part for your car, rather than car companies holding all the stock for all the bits they've ever made for every model, they can just be printed on demand from a software program. So that's where we see it going over the short term. Already the military are using 3D printing out in the field to print replacement parts they can't get. But it also is quite interesting because it allows for new structures to be possible. So I've got a few examples here of 3D printed structures, which I'll hand round. Please take a look at them, but I need them back, so I'll pick them up at the end. But these were made in one printing process, and they couldn't be made in any other way. And as these go around, you'll see the reason why. But companies like Airbus and Boeing have told us that they're very excited by 3D printing because there are optimal aircraft structures which they cannot make cheaply using conventional processes. But 3D printing, for the first time, allows them to make these better aircraft structures using that technology, which will be cheaper and lighter weight. Airbus even said at one of our events on 3D printing that by 2050, they hope to print most of an aircraft. We don't know if we'll get there or not, but it's interesting to watch. So yes, there is lots of hype, and it's a smaller market, we think, than other analysts put out. It's about $1.5 billion last year. We think going to about $4 billion by 2025, but this is the market size spent on 3D printing equipment, not the value of the products that they produce. And there's a whole shift in materials, people developing better materials, metals, plastics, wood, ceramics, and so on. So there's a huge material opportunity as well as a printing one as well. So that summarizes my talk. For more information, we host events on printed electronics and other topics. The next one will be in Berlin in April. But I hope you found that brief introduction to these technologies helpful. And I'll hand back over to Andrew.